Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. We are a student of Qasim University College of Engineering Physics 104 group 3 and 4. We are going to do the experiment of Ampere's law, the coil. Before we do the experiment, we must know the goals of this experiment, which first, determination of the magnetic field for a coil as a function of the current. Second, determination of the magnetic field for a coil as a function of its length. Third, determination of the magnetic field for a coil as a function of the number of turns per unit length. We have the equation of this experiment, which B equal mu naught times I times N over L, which B is the magnetic field and mu the permeability and I is the current and N is the number of turns per unit's length.
We're going to study this function, but we can't study it as many variables. So we're going to make all the variables constants except two variables, and which are B and I, because we're going to study the magnetic field. So we're going to make the N, the number of turns, and the distance constants. So we turn on the Tesla meter. We press the composition to make it 0 or near 0. Second of all, we turn the power supplies on. We turn to 0. The distance is here between the whole sensor and the coils. It's constant. We're not going to change it the whole experience. And the number of coils per unit length, we're not going to change it. We're not going to change the coils. First of all, we see the Tesla meter says 0 here. Second of all, the I, that current is almost 0. We turn the current on, turn it to 2. We see here the Tesla meter get read 0.3. That means the magnetic field got higher. And we're gonna see if the magnetic field is the relationship between B and I is direct or indirect. We turn it on, we turn it more to 4. We can see here at Tesla meter it's more and higher. That means that we go higher by current, we get more magnetic field. We just studied the relationship between the magnetic field and the current. Now we're going to study between the magnetic field and the coils, the number of coils on the length unit. So we're going to replace the N by L by N small, which means N by L. Like what we did before, we're going to make two of the variables change and the other variables constant. So we're going to make the current at 5 a constant, and we're going to make we're going to change the length between the higher number of coils per unit, and we're going to see if there's a change in the Tesla meter here. First of all, we get a read 0.86, 0.87, and the higher number here. So we're going to go farther to the lowest numbers here. We're going to read here 0.62, and that's lower. So the higher number of coils is equal to the higher number of magnetic field. So we're going to go farther right here. And the number of coils here is less than here, and it's either less than here. So we're going to read 0.39 or 0.4. And that's proof that the number of coil, the bigger number of coils equals higher magnetic field.